So we built it. Got my components turned out surprisingly very close. I took a wrap or two off of this guy, and I got the perfect 180 microhenry, and I wrapped this guy with like 3 or 4 taps, and then the very first tap that I put, I missed it by 1 wrap, so I fixed it, and I got 4.3 millihenry out of that very nicely. So I'm just using the very first corner of this, and then these caps over here add up to 1.5 microfarads for the differentiator. And this is a traditional N-channel MOSFET, same one I used in the boost converter. That seemed to work very well. I'm putting about almost 12 volts in there, using about 50 milliamps. So I'm a little bit confused from what I see is that if I turn up the gain on the square wave, what you'll see happen is yeah, we get a lot more high-end ringing, but the power goes way up. If I can back off where I had it, you know, down to the point where it's almost using no amps, and we're just getting noise through there. But if I bring it up, it's definitely using more power. However, I don't think it's 30 watts. With the 12 volt input supply, you know, when that 180 microhenry choke is charging, this is really that current's most likely only the on-time charging, right? So it's just, it doesn't make sense yet. But there's definitely a nodal point here right at 1.9 kilohertz, but minor fluctuations in the component. Obviously, I can tune it up and down a little bit just to get it there. But these are the same nodal points that we see with the any type of resonant tank circuit where we have reflections going on. So this is very indicative of reflections happening in this series resonant leg of the circuit that becomes isolated due to the DC blocking of the capacitor, but allows AC amplitude or signal level only to go through there. And that's what we see until we really crank it up, and then we can get a decent amount more ringing going on. But you'll see as I get to the nodes, we back this out. It's better to look at it over long term. We see a bunch of spikes happen. Now when I adjust it up or down, so anyway, this right on the nodal point where there's a coherence cancellation, right at my circuit, it looks to be, get it back, the delays makes it hard to tune, right at 2 kilohertz, it seems to cohere and flip the other way. Interesting. So I'm not quite sure why this what this scope shot is actually showing, since it's marked kilowatts, but it's a sinusoidal reading, and it says inductor, and it's not specific on which inductor, obviously. Presumably it's this one, and this voltage source is more of a pyramid wave with a little bit of noise going on there than an actual straight square wave. But there's no indication of the gain applied on the square wave either that's making this act more like a transistor than a MOSFET. Specifically running 159 watts through it. This doesn't make sense to me. How could you be pushing 156 watts if you have 12 volts and the particular reactance at 1.9 kilohertz is approximately 1.1 watt It's not getting hot until I crank it up. If I crank it up, that's the weird thing. If I flip this on AC over here, watch what happens to the wave goes nuts and the current goes way up to almost 6 watts, and that does heat this up a little bit, but it doesn't with it on 50/50 square. But yeah, there's definitely some resonant spikes that cumulatively occur in there, which is typical of the coherence point. Pretty cool, huh?